Okay, we're talking about the JFET amplifier. Okay, so basically, they will be using JFET to amplify the AC signals. And they're telling you one reason why we're using JFET, okay, instead of bipolar. Only thing is JFET get a very high input impedance. Okay, however, JFET have a not much gain. And also JFET amplifier, we get three configurations: common source, common gate, and common drain. Like in the bipolar, you get common emitter, common collector, and common base. And whoever wants to convert it from the DC JFET circuitry to AC JFET circuitry, then you have to be follow the step we already listed here. Okay, like I said, on DC source will be sorted to route. On of the capacitors will be sorted. That means you cannot see any more capacitor in the AC module. Okay. And also remove all of the element bypass by short circuit. You understand, if you get a bypass capacitor, they have to be shorted. And now you redraw the circuitry for AC. And this will be show you basically inside. This is a DC circuit. And this will substitute that DC by AC circuitry. You still get the gate, you get the drain, and you get the source. From the gate to the source, you get the VGS. And from the drain, go to the source, you get the current flowing. And the value will be GM times VGS. This is the internal output resistance of the JFET. That is a very high resistance, so that will be ignored, okay? And now, the first, you can see we get a common source amplifier. And the common source amplifier display here, they're using the fixed bias to build the amplifier. So you can build the amplifier either using the fixed bias or using the cell bias, or you can using the voltage divider bias. That doesn't matter. Okay. However, what I want you, when you're looking into the circuitry, you're able to know, is it a source amplifier or drain amplifier or gate amplifier, okay? And what happened to the input and the output? So for the source amplifier, input apply to the gate and output from the drain, okay? And also, they can telling you the input and the output will be 180 degrees out of phase. That's a very, very basic thing for anyone. Have to know. Okay. And now we redraw the AC circuitry for circuit. I get to give it to you. In the fixed bias, this is V in here. And the battery minus VGG, they shorted to the round. Okay. And also you can see you get a VDD and now VDD will be short to the route. Okay, I already deleted internal output resistance. We don't care on that one. Okay, so this is the AC drawing for the circuitry we just given to you. Okay, and now this will be given a little more detail. This is V in, this is VG, and from here to here, that's the VGS. Okay, and it's the output. You can see at the drain, you can get the only one resistor will be connected to the ground. That will be RD for that circuit. So the output resistance, you're looking into the amplifier, Z out. In this case, they equal RD. So this is the basically formula, okay? They given to you V out equal minus GM VGF. That means the current here times RD. Minus sign, that's telling you input, output will be opposite. Input positive, output positive, okay? And input positive, then output negative. Now, VGS, that means the voltage from VG to the S. Same thing with the V in, okay? So, V out now you can get calculate equal minus GMVI, okay? Instead you say VGS, now they will be equal VI times RD, and that's what you can get the gain, okay? The gain AV will be equal V out divided to V in, and that will be minus GM times RD, okay? So however, if you get the load resistance at the output, then the gain will be little different. The thing is, output impedance now not equal the RD only. They will be combination for RD parallel to IL. And this one, we already talking to you here today. You want to talking about 7 here, right? Mr. Smith.
Correct, yes.
Okay, now let's see. For the fit bias configuration, okay, they given to you VGSQ minus 2 volt.
Right.
And IDQ equal 5.6 to 5 milliamp. And IDSS, they given to you 10 milliamp. VGS equal minus 8 volt. That will be VGS off, okay? Make sure.
Well, you have on your schematic, you have V pinch off equal minus 8 volt. So if pinch off is minus 8, then VGS off has got to be plus 8.
No. That's the N channel.
Then your pinch off should be plus, shouldn't it?
Right.
Okay, so yeah, okay, so I messed up. Okay, so your pinch off should actually be a plus 8, and then your off should be a minus 8.
Yeah, you know, in the book it's wrong. That's why I get from the
Yeah, I understand, Mr. Pham. It's just a typo because you know what you're doing. But yeah, I see now. Yeah, the VGS has got to be a minus voltage.
exactly.
And then then the pinch off, which is the same magnitude but of different polarity, would be plus.
Right.
Okay. Yeah. All right. Okay. Go ahead with the rest because I want to see how much I got wrong.
Okay. So basically, that I get schematic from the one of the university. Okay, they did it wrong. The thing that you understand the N channel VGS off must be negative. If the P channel, then VGS off, VP will be negative. Okay, VGS off will be positive, opposite. Okay. And they wondered what the GM, okay, phi RD. So number B, we don't have to find that RB. RD. Number B, that's an internal output resistance. If you want it, then you have to go back in here, try to find out. Let's see.
Up.
Up.
Right there. You passed it.
Which one?
No, you passed it. Stop right there,
Here.
right there, right there.
Right here. Okay. If you want to calculate the RD, external output resistance, internal output resistance of the JFET, you're using that formula. Okay. But the thing is, what I'm saying is, this resistance is too big, so they will be ignored all the time. So we don't have to do that calculation.
If I could just ask any of the other students out there, what did somebody get for letter A? I think I got it wrong.
What do you mean letter A?
Letter A, it says determine GM.
Okay, GM. What the formula to calculate the GM?
GM is, I wrote it down here somewhere. Oh, GM is equal GMO in parentheses 1 minus VGS over VGS off. And there's no square.
Okay. Okay. You want GM, right?
Right.
Equal GM 0.
Right. So you need to figure GM 0 first, but go ahead.
Minus VGS.
Over VGS off. Close parentheses. Yeah.
Okay.
Mm-hmm.
And what GM equal? 0.
Right.
GM 0.
Right.
You've got the formula.
GM 0 equal 2 times IDSS
Okay. 2.
divided by VGS off absolute value.
Okay.
VGS off absolute value. Yeah. I tried to do this, but I think I got some of my calculations wrong. So I don't know.
Okay. Now let's see. Calculate the GM 0 first.
Right.
2 times IDSS means 2 times 10, right?
2 times 10 milliamps. Right.
Divide minus 8 will be 8, right?
Well, that's another thing. I think I might have put +8, but yeah, it's because we talked about that earlier. Yeah, but then the absolute value of either -8 or +8 is just 8.
Right, exactly. They don't have a negative for the GM 0.
Yeah, I messed it up.
2.5, right?
What did somebody else out there get?
Two 4.5 is correct.
Yeah, I got 2.5 as well.
2 times 10 divided to 8.
Is that 2.5 micro or anything like
Yeah.
that?
And what GM 0 you get?
Wait, Mr. Pham, you put milli. Is that micro or milli?
Milli.
Oh, that's milli?
Yeah.
Okay.
GM equal GM0, that means 2.5. 1 minus VGS Q minus 2 divide minus 8.
So that's 2.
Is it 1.875?
Correct. Millisiemens.
Yeah. Okay.
All right.
Now, number C, input impedance.
Oh, the input impedance for C, that would be infinity, because you said we're doing a JFET, it's got high input impedance and up
But
top.
yeah, that's what they expect that to be, but depending on the circuitry. Now on this circuitry, they want to know what the input impedance. G in.
Yeah, I just wrote infinity.
Oh, no. They want it to be infinity, but they cannot. If they looking into the JFET, only one they can see. One mega ohm. That means this resistor right here.
Okay.
Output impedance, G out. Normally, if the student understand it, you can get it done really quick. What G out?
Okay, so is that the same as the resistor, which is 2K?
Exactly.
So Z out is 2K.
The thing is you get only 2K, no
No load resistor.
Exactly.
Okay, so
Okay, so we're not doing on number E. The thing on number E, they want to calculate using also internal output resistance of the JFET mean RD. We're doing number F. What the formula?
let me see. Again, I use should we be using GM times the big RD?
That is depending on the formula right here, right? AV GM times RD.
It says AV equal V out over VN equal minus GM times RD. So is that the one we're supposed to use?
Yeah. However, we're not using the minor
So it's just GM times RD.
RD. That's for AC signal. The minus side just telling you, okay, they opposite. 1.875. RD chu kỳ. Remember, one will be milli, one will be chu kỳ. So they cancel out.
Wait a minute, you said GM times the big RD, right?
Right.
So it's, what was GM? GM was 2. Oh, GM was 1.875 times 2K. That's 3.75.
Yeah. That's what I get.
And Mr. Pham, one last thing, on number B and number E, what was the reason we don't do B and what was the reason we don't do E?
That means they want to get involved of RD.
Mhm.
RD means internal resistance.
Yeah.
And if you want it, you have to do calculation RD right here. And that RD, we already given the formula, right? They will be 1 over YOF.
Okay.
Okay, whoever want it, then you can do. Okay. And YOS right here.
Right.
Okay.
Okay.
The thing is it is coming from the university. So that's why engineering, they have to do on off those calculation.
All right, Mr. Pham,
Yeah, you're welcome.
thanks a lot. You got them better than I did. Thank you.
Okay, now on that one, how they build this common source amplifier, what the bias circuitry will be using.
Well, is that like self-bias, you mean?
Exactly. That is the first thing when you're looking into the amplified circuitry of the JFET, you have to know what bias they're using.
Because there's no battery where the 1 meg is at. So that's why it's self-bias.
Exactly.
Okay, thank you.
Now, before you're going to do any AC calculation, you have to do a DC bias first. Okay? And for the cell bias, what happened? They supposed to give to you the graphic to solve the problem. However, they don't want you using a graphic. So that's why you can see they given to you here. That means given Vs equal 1 volt. So that's why without the graphic, you're still doing calculation, everything. Okay? So now, what I want you to do.
Hey, Mr. Pham, can I ask a question real quick?
Yeah.
On the, say like if you want to know VGS, VGS is VG minus VS, is that right?
Exactly.
So, so like in the center there, where you drew that 1 at, where's the VG, where's the VGS and all of that? Can you go over that like real quick?
That's a basic, right? VGS equal VG minus VS.
Okay,
What VG equal?
VG is equal to, I don't know, that's what I'm asking you. VG is equal to, well, we know VS is 1. VS
Okay,
is,
but the thing in my question is what VG? You tell me. That means on the DC bias, you still cannot understand. What VG equal?
E in.
Come on, we're talking about DC bias.
it's the voltage from the gate to the ground. VG is the voltage from the gate where that black dot is at. It's from there to ground.
Let's see, 2, 0.
That is the gate right here.
Right, right, right.
1 volt.
So from there to ground minus the 1 would be VGS.
Then the formula will be VGS equal VG minus VS. But my question is telling me what VG equal on this schematic.
I'm taking a wild guess. 0?
No.
Okay, now, if I want to measure the VG, I given you the meter, how to make the connection, positive to the gate, right?
Right, and the black lead to ground.
Right. So what do you think you get?
1 volt. Minus 1 volt.
Then
You have to telling me
VG
VG equals 0.
VG equals 0. So I guess right. I didn't know, but I guessed right. So it's 0 minus 1, because VG is 0, and then you gave us the VS, which is 1.
Exactly.
Okay, so VG is 0. Okay, all right. Got you now, Mr. Pham. Thank you very much.
You're welcome. Try to be like myself, okay? When you're looking into that, you're able to know right away. We already go through that DC bias.
Okay. That means I got to look at your video over and over.
Yeah, just for a while, you can get along, okay?
Yeah. Mhm.
Like myself, I keep going. Now, I want ID.
If you want ID, I is equal to the voltage divided by the resistance. So it's 1 volt divided by 200 ohms, and that's ID.
Exactly. Basically, you're talking about IF, right?
Yeah, but you said ID and IS is the
Same.
same.
All the time,
Right.
okay? They will be VF divide IF.
So on your calculator, you just take, put
1
in
volt.
200 and hit the reciprocal button, and that's ID.
Okay?
Yeah.
So 1 volt divide 0.2, what you get?
You get 5 milliamps.
Okay? Now I want to calculate the VD. Formula will be VDD ID time RD. You calculate telling me what I supposed to get.
7.5. 7.5.
Okay, one student gets 7.5 volt.
Yeah, because it's 5 milliamps times the 1.5 K, and that's 7.5. And 15 minus 7.5 is 7.5.
Yeah.
Okay, that means every time you get the amplifier, DC bias must be done first.
Mhm.
Okay, then we can deal with the amplifier AC circuit. Okay, any question up to this point? That a DC bias we already calculated. Okay, if it's not, what the C in or C out? What is the name and the purpose for those capacitor? C in and C out.
CN is a coupling. That's the pass AC and the block DC.
Exactly.
And
What happened?
the other one is just the bypass.
No, I'm talking about C out.
Oh, C out, that's coupling too.
Okay, perfect. Okay. They're telling you at the drain, you get a sine wave AC signal. And also you can get a 7.5 volt DC. However, when you go to the output, the load, you don't have any 7.5 volt DC anymore. The thing is, C out will be blocked at DC. Okay, the last capacitor will be CS 100 microfarad. Farad, that will be bypass capacitor. Same thing like in the bipolar.
And we're bypassing the what? We're bypassing.
Bypass are at 200 ohm.
So that what happens to the AC signal there?
We don't have any AC at the, let's see.
You're talking about the CS.
Yeah, CS, they will be shorted to the route.
The AC gets short the ground.
Exactly.
Okay, thank you.
That is a bypass. Okay, now on that one, they given you V in 0.5 volt, peak to peak. Okay, now we see. Let's see. This is what we need to do it. Okay, on this they just given the formula. They just given to you G in equal RG. That means right here.
Mhm.
That's what we just done it.
Right.
E out. That means RD parallel with R small d. That means internal output resistance. But I said we don't care on that guy. Okay,
You don't care what little RD is.
right. So that's why,
So yeah, but Z out is equal to the big RD, which you crossed out.
right here.
Right.
Okay. If they say, see right here, RD bigger than 10 times of big D. I can give you the example here. You get 1K resistance parallel to the 10K. What are equivalent?
If you got 10K in parallel with 1K,
That
the
means a
answer,
big resistance parallel with a small resistance.
a big resistor in parallel with a small resistor would have to be at least 1K or less.
Okay, so that means you can get a 0.99 whatever, right?
Right.
Okay, so almost 1K. So that's why they're telling you RD higher than 10 times of R big D. So that's why they ignore R small d.
Right.
And now, if you're looking into this formula, okay, they given you want to calculate the current gain. They will be minus EM times RD.
You mean the voltage gain?
Yeah, voltage gain. And also, if they doing including R small d, then you have to calculate the R small d parallel with R big D. But what I'm saying is we don't need that. Okay. And
It'll just be,
amplifier at a 180-degree phase shift between input output.
but Mr. Pham, the gain is just, forget about the minus, it'll just be GM,
RD.
GM times RD,
Exactly.
the big RD.
Big RD.
Yeah, okay, thank you.
The thing is negative here, just telling you they opposite.
Okay.
Okay. AC, they cannot get any negative voltage.
Okay.
Okay. On that one here, they already telling you they want VGSQ. Okay, quickly. Try to see we can get through this guy. VGSQ, that means at the Q point. VGS, we already did it, right? That's a DC calculation. We already know that VG minus 1 volt. IDQ, we already calculated. IDQ equal what? IDQ 5 milliamp. VD, we already calculated equal what?
It was 7.5 because it was 5 milliamps times of 1.5K is 7.5 and 7.5 from 15 is 7.5.
So, okay, next semester I have to review, okay, for this JFET. Otherwise, they will be confusing. The thing I did basically coming from the one I take from one of the university. Okay.
In any case, it's 7.5, Mr. Pham.
Yeah, 7.5 volt.
right.
GM0,
GM0 is, what
2
was-
times.
GM0 was 2.5 millisiemens. I forget what it was.
IDSS is it equal 10 or what?
IDSS was 10 mil, yeah, IDSS was 10.
Okay, so they will be 2 times 10. Divide VGS is minus 8, right?
Yeah, -8.
No, 8 minus 4.
Minus 4.
Yes.
4.
It's right here in the circuit, right here. Right on the number said VGS off, -4.
Okay, right here. Okay, 10 milli. Thank you.
Oh, yeah. So it's the absolute value of that, yeah.
5, right?
Yeah. Sam got eagle eyes.
Okay, and GM. GM0. Okay, telling me what you get.
Yeah. -1 divided by 4.
VGS we already calculated equal minus 1 volt. So basically they will be 5 times 1 minus VGS we already calculate equal minus 1
-1
minus 4.
-4. So in parentheses there, that'll be 0.75
and 5.
times 5. Minus the plus.
3.75, right?
Okay.
Yep.
Okay, AV gain. What's the formula for the gain?
So it'll be the GM times the RD.
They will be GM times G out, not RD. G out,
Yeah, we're talking about the big RD.
1.5K parallel with what the gate,
Oh, yeah.
what the load.
Oh, that 10K.
10K.
So it's 1.5K in parallel with 10K. Is that right?
Exactly. So 1.5 times 10 divide 1.5 plus 10.
So that's basically 1,300 ohms or something like that. Did anybody get 1,300 ohms?
1.3K.
1.3, yeah.
Okay,
All right.
so GM will be 3.75. Time 1.3K. Okay. I get 4.875. That is the game. Input impedance,
1 meg,
output impedance. We already calculated
yeah, so that's
1.3K.
1.3.
Okay, and adding one more. I want V out.
So it's the gain times VN.
Exactly. AV times VE. AV will be 4.875. Time 0.2. Zero point 0.975. That means this is a completely calculation for the common source amplifier.
Teacher, is B zero output, B output negative?
Can you say again? What? Okay, so that is a completely calculation for this common source amplified circuitry. If you can feel anything you don't know, just bring it up. You can will see that in the final. I just a minor change something. And if I get a time, so I can be divide this and out to get it much better for you guys to follow it. Okay, now you do this for me. That's what I'm telling you. On the final, you can get the circuitry. Same thing. But if not, everything will be identical. Just a minor changes. You understand it, you can do it. Okay, so go ahead and try to see, okay, we can get through for each question. Almost the same exactly, we just did it. Just a very minor change. Who get the answer, let me know. So I try to collect the right answer for some student cannot following it at this time. VGSQ. You know, we don't using the graphic. In this case, they given you the current ID equal 1.95 milliamp. And basically you understand VGS equal VG. Minus VS. In this case, what you need to do is calculate the VS.
$1.77.
So you get the answer for number A. Is it right? I want the answer for number A.
$1.77.
I also got 1.77.
Correct?
VG is 0.
VD.
You got negative sign means VG is 0.
You mean VD equal 0?
You wrote VGS is equal to VG minus VS is equal to negative 1.77 volt. That you wrote it right now.
Okay, now let's see. VD mean the formula calculation equal VDD ID time RD. VDD equal 12 volt minus RDID. ID they given to you 1.95. Time 3.3K.
6.43.
Is 1.95 milliamp.
ID equal 1.595 milliamp.
Mhm.
The,
So
the
we-
voltage, the voltage drop across RD should be 6.435.
5.6.
So I get 5.56 or 5.57.
I got 5.56.
Yeah, that's okay.
5 EE 3 negative times 3
We had 1.77 volt.
6.1.
So basically, this problem have to revise. We have to calculate the VS before we calculate the VGS. Okay, we'll be make that correction. Okay, you calculate the GM0. Okay, 2 times IDSS. Divide absolute value. I just want the answer.
I believe it's 3.
You get 3?
I believe so. 12 times 2 is 24. 24 divided by 3. 24 divided by 3 is 8. Sorry.
So one student get the 3 MS. Anyone get a different, let me know. Then you can telling me GM on number E. The formula GM will be GM0. 1 minus VGS.
Mr. Sam,
Yes, sir.
for DGM0 is answer 3 millisecond or 8
Now,
millisecond?
millisiemen.
Millisiemen. It's
Yeah.
3 or 8?
I think it should be 8.
8.
Okay, you said you should be 8. Okay, that's what I asking. I do not do calculation. Okay, thank you.
Welcome.
And GM equal. You guys calculation, I'm not. Okay, what GM equal?
3.28.
You get 3.28? I don't know, we see anyone get the same.
Check.
I got 3.28. That's correct.
328, right?
3.28.
If you get a different answer, let me know. Okay. Number F, input impedance. 110 mega ohm.
10 mega ohm, yeah. Same as
Output.
RG.
Output impedance.
Output impedance, if you don't have a load, it's going to be 3.3.
3.3K.
You got to put a point in there, Mr. Pham.
3 point.
Yeah, you look like you got 33K. It's 3.3. Make a big dot.
Okay, so let's see.
Equal 3.3. Okay, there you go. There you go.
Okay, number 8, voltage gate.
Is that 100 millivolts?
Voltage gate.
Yeah, I know, but I'm saying the input.
Right.
volt. Is that 100
millivolt?
100 millivolt?
Yeah.
100 millivolt, yeah, times,
No, I want the gain first. Number 8.
yeah, you want the gain. So that's GM times, times RD, the big RD.
Okay. GM, we already calculate 3.28. 3.28 times
times 3,300.
3.3.
10.8.
10.8, correct. Telling me last one, 3 out. That will be gain time EV in 100 times
100 millivolts times 10.8. That's 100 millivolts times 10.8.
is it a 1.1 volt?
Yeah, is it?
Okay, so that is a completely calculation. Okay, get any question up to this point?
Teacher, I have a question.
Yeah, go ahead.
The last one, voltage of output, should be negative because it's 100 degree opposite.
100 millivolt times 10.8. Yeah, 1.1. That will be voltage, not milli.
Yeah, voltage, but I'm talking about the negative.
No, 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 no.
Not necessary, right?
AC not negative, positive.
Okay.
Okay, so up to this point, any question, anything? Make sure when you see this kind of the circuitry, you're able to get it done quickly. That's what I like to see, you know, that I'm able to do it. Then you
Oh,
will-
I see what you did. You took the 10 point, you took it was 1.08, but you rounded it off to 1.1.
right.
Okay, yeah.
Okay, so basically, let's see, source follower, common drain. Okay, so if you get the time, try to go through the common drain amplifier. We'll be talking about next meeting. Okay, that will be help a lot. So now, Mr. Sam,
Yes, Mr. Pham.
you ready for the quiz number 9, right?
Did you uploaded the assignment on there?
Oh, okay. I want to see.
Yeah, it's not up there yet.
Okay, thank you.
You're welcome.
I do it now.
Okay.
Let's see. I will get out that guy.
So what quiz is this?
Quiz number 9.
Number 9?
Okay, that for well, I loaded, uploaded. Hmm.
Sam, should we start the quiz and then at the end of the quiz, we download the Excel sheet?
Yeah, if you have a sheet of paper, just write down your answer. It's going to be 18 questions, just like the quiz number 8.
Yeah,
So,
so let's get started and then we can download later.
okay, so is everybody okay with that? Okay, so let me go ahead
Yes, you
and
can.
run it. Okay, let's go ahead and get started. Okay, share screen. All right, share. All right, let me go ahead and get started. Okay, here we go. Can you all see that?
Yeah.
Okay.
Question 2 and 3 is the same.
Yeah, so just go ahead and just choose your answer the same then.
Okay, so I already uploaded.
Okay. Okay, so that's pretty much it. Make sure you upload to the website. Let me go ahead and stop sharing. Now let me see what was on the chat there.
I'm sorry, Sam. Can you just show the first ones again? 1 through 3 and 4 through 6.
Okay. Okay, so that's 1 to 3.
Perfect. Thank you.
That's 4 to 6.
Got it. Thank you.
Welcome. Okay, so that's pretty much it. Make sure you upload to the website. I know that Mr. Pham already upload that onto the website. Let me see, just check this to make sure, just to confirm it. Yeah, so the quiz report is on the website, so make sure you download it, put your answer on that report and upload it to the website. Okay, thank you very much. Back to you, Mr. Pham. Thank you.
Thank you, Sam.
You're welcome.
Okay, thank you, Sam. Okay, so good night, everyone.
Good night, everybody.
Night.
Good night.